Welcome to section 2.4, slope is a rate of change. So we're going to be talking about the average rate of change, and the average rate of change is a ratio. So change in y over change of x. It's normally for like applied problems. Okay, so because it's normally like applied problems, like real life problems, that means units are normally included with the average rate of change. And the average rate of change is similar to the slope because it's the change in y over the change of x. The only thing that's a little bit different is it doesn't necessarily have to be a linear relationship. So for instance, if we have a graph that looks like this, definitely not linear, we can talk about the average rate of change, let's say from point A to point B, right? And then it's just the change in y over the change of x, all right? Something like that. Okay, but we can also look at the average rate of change for a straight line, and if the linear relationship, in a linear relationship, the rate of change ends up being exactly the slope. And if the rate of change is constant, then the relationship is linear. All right, so constant rate of change would give us a straight line. Notice in this curvy line that we drew right here, the rate of change, how the line is changing, is not constant. For instance, down here, our line is changing rapidly, and then we're slowing down, and then right here, our line isn't changing at all, and then it's changing in a negative direction, and then again, not at all right here, and then again, we're going to start changing in a positive direction rather quickly. Okay, so the rate of change is all over the place, versus right here, the change in y and change of x is always the same thing, and it's the slope. Okay. All right, so let's go back to this example from the previous section. Despite the No Child Left Behind Act, students' averages math score on the SAT decreased approximately linearly from 518 points in 2006 to 514 points in 2012. All right, so remember we counted t, the independent variable, to be years after 2006. So we got these two ordered pairs, and now they want us to find the average rate of change of the SAT math scores. Well, it's approximately linear. And so if we're going to find the average rate of change, that's the slope. So again, we can look at the difference of our y values. I'll start with that point because again, it doesn't matter. Over the difference of our x values. All right, and we said it was negative 2/3. Okay, so this is what we were doing in the previous section. Remember, units are normally included with the average rate of change. So let's have our answer be this. Let's have it be negative 2/3. But let's think of the units. So remember, it's the change of y over the change of x. All right, the y values were points, and the x value was years after 2006. So we have points per year for our unit. So this could be negative 2/3 points of a point each year after 2006. All right, so a little bit of a unit analysis. Okay, so let's look at example 2. The number of U.S. brewery openings was 154 openings in 2010 and has increased by about 12.4 openings per year. We want to find an equation of a linear model to describe the situation. Explain what the variables represent. Okay, so we could do this. We could let T be years after 2010. And then we could let B for brewery be breweries opening or amount. Here, let's just rewrite that as the amount of breweries opened that year. Okay, now let's write an equation, a linear model. So it would be a function of time, so B of t. So notice that we had 154 openings in 2010. Well, if t is years after 2010, that 154 is like the y-intercept. All right, isn't that clever? And then notice this next part. They're increasing by about 12.4 openings per year. That's telling us a rate of change because they're giving us the amount of openings each year. So that's really behaving, remember, rate of change is like the slope. So we can actually use this formula, y equals mx plus b. All right, where we're increasing by 12.4 openings per year. That's telling us the rate of change each year. That's going to be behaving like the slope. All right, so filling in the pieces, our m is 12.4 times t. And then we're starting at 154. All right, and there's our linear model. All right, so now we're going to perform a unit analysis of the equation we found in part A. So let's write our equation again. And we're going to write the units down below. So B of t, remember, is the amount of openings. That 12.4 stood for openings each year. Per is another way of saying divide. So openings per year. T stood for years after 2010, so T is a year. And then finally 154 stood for 154 openings in 2010. So we could write, again, that's 154 openings. All right, so notice that this first term, there's a year in the top and the bottom, so that's going to cancel. And notice we have openings now left on the left. And then we can add like terms, really. Openings plus openings would just be more openings. So we see that the unit analysis, everything ends up working out perfectly. So we're good to go right there. All right, and then the slope of our model, again, it's a linear relationship since we've been increasing at a constant rate. So the rate of change was constant. So we know it's linear. So the rate of change is slope. And it was 12.4. And it stood for openings per year. So every year, about 12.4 breweries opened. All right, and then finally, we can use our model to make predictions. We're going to predict in which year there will be an average of 5 openings per state. Okay, so we have 12.4 T plus 154. That's our linear model for how many openings per year. And we want to know when there's going to be 5 openings per state. Okay, so we have 50 states. So 5 openings per state would be 250. So we want to know when our linear model is going to have an average of 5 openings per state, or 250. All right, so we're going to solve this linear equation for T. So we're going to subtract the 154. And then divide out by the coefficient. And so we get T is 7.7 years, let's say. So remember, it's 7.7 years after, let's go back up, after 2010. That's what your T is. So they want to know in which year will there be an average of 5 openings per state. Well, it's going to be 2010 plus 7.7 years. So we'll be about more than halfway through the year 2017. So yes, technically the answer is 2017.7, but that would put us in the year 2017. So in which year 2017 is our solution?